Hello dear learners, I am Dr. Nishant Yadav. Welcome to lecture 15 of the course on Essentials of Surveying Applications and Technique. In this class, we will discuss about the 5 fundamental lines or the 5 fundamental axes of theodolite, and also we will talk about the adjustments in theodolite. In the previous lecture on theodolite, we have seen various advantages of theodolite surveying over chain and compass surveying, and now we are clear why theodolite is more preferred over the other conventional survey instruments. The specific answer for this preference is its versatility, speed and accuracy. We talked about various applications of theodolite in field surveying, and we also discussed about the various components of the theodolite. And in this lecture, we will continue to build our discussion from the components of theodolite. But before moving ahead, we will revisit some technical terms which we will use in this and also in the coming lectures. The first term is the line of sight or the line of collimation. It is defined as an imaginary line joining the points of intersection of crosshair of the diaphragm and the optical center of the object, the glass and its continuation. In this definition, we find two terms. First is the intersection of crosshair of the diaphragm, and the second term optical center of the object glass. Let us dive into this definition and explore. Now consider this as a telescope. In simple working telescope, it requires nothing but a pair of lenses mounted in a tube. The lens in front, that is towards the object, to be sighted is known as the objective, and the lens in back, that is towards the eye of the observer, is known as the eyepiece. In the telescope tube, there is a glass called diaphragm, and on this diaphragm crosshairs are present. Crosshair is obtained by intersection of two very fine lines placed in a common focus of the object glass and of the eyepiece. This imaginary line, which passes through the intersection of crosshair and the optical center of the object glass, is called as line of collimation of the telescope or the line of sight of the telescope. Usually, one crosshair is horizontal and the other crosshair is vertical, but in some instruments the crosshair are arranged in the form of alphabet X, which is thought to enable the object to be bisected with little more precision. Now, extending the same concept and look into the other definition of axis of telescope. Axis of telescope is a line, the optical center of the object glass and the center of the eyepiece. Can you guess the relation between these two lines, axis of telescope and line of collimation? Yes, the axis of telescope and the line of sight or the line of collimation must coincide with each other. The next term that you should know while using a transit theodolite is transiting. We know that there are two types of theodolite, transit theodolite and the other is non-transit theodolite. During operations with theodolite, transiting means to rotate the telescope by 180 degree about horizontal axis in the vertical plane. It is also known as plunging or reversing of telescope or theodolite. Next term that we are going to see is swinging. In this, it is the process of rotating the telescope of the theodolite by 180 degree about the vertical axis in horizontal plane. So, what is the difference between transit and swinging? In both cases, the telescope is rotated by 180 degree. Hope you guessed it right. The difference is in the axis about which the rotation takes place or the plane in which the rotation takes place. In swinging, the rotation takes place the rotation of the telescope takes place about the vertical axis in horizontal plane, while in transiting the rotation of the telescope is about the horizontal axis in the vertical plane. Confused? Some terms are very familiar, but they are slightly confusing. Let us see what exactly we mean by vertical axis and horizontal plane. Suppose this is a vertical axis and this is a horizontal plane. So, if I rotate this vertical axis, along with this the horizontal plane also rotate, and if this is assumed to be a horizontal axis, the plane associated with is vertical plane. So, if I rotate the horizontal axis, along with the horizontal axis the vertical plane also rotate. So, the definition of swinging and transiting will now make better sense. Again we will define transiting is the rotation of telescope by 180 degree about horizontal axis in the vertical plane, whereas swinging is the rotation of telescope by 180 degree about the vertical axis in the horizontal plane. Now that we are familiar with the terms like swinging and transiting, we can now discuss two terms, face left and face right. For this, you need to look at the components of the theodolite again. Find the component called vertical circle. It is adjacent to the telescope. While taking observation, if the vertical circle of the instrument is on the left side of the observer, the observation or the instrument is said to be face left, and the reading taken in this position are called as face left reading. Consider this to be the telescope and this to be the vertical circle. So, while taking observation, if the vertical circle is left to the observer, so this kind of reading is called face left reading, and the instrument is said to be set in face left position. Similarly, face right readings or face right. When the vertical circle is present on the right side of the observer, it is known as face right, and the observation are termed as face right observation. So, the technical terms phase changing refer to the process of transition of vertical circle from left to right or vice versa is called as phase changing. Again look, this is the telescope, this is the observer, and this is the vertical circle. So, if the vertical circle is on the left of the observer, this setting is called phase left, and suppose the vertical circle is on the right side of the observer or right side of the telescope, this reading would be designated as face right readings. Some of the terms may be confusing, but with little practice and consideration it will be easy. Now, moving ahead, we will talk about the 5 fundamental lines in theodolite. Theodolite, which is an optical instrument which is known for its accuracy and precision, and it can measure horizontal as well as vertical angle. So, there are some fundamental lines which the user of the telescope or the theodolite should know before using it. The fundamental lines are the vertical axis, it is also called as azimuth axis. Horizontal axis, it is also called Turnian axis. The line of collimation or the line of sight, the definition of which we just looked at. The bubble line, also called as the level tube axis and altitude level axis, and last but not the least, plate level axis. Again look at the components of theodolite. You will find there are horizontal axis mentioned, it is nothing but the Turnian axis. We have come across this term Turnian axis or the horizontal axis numerous times in our discussion. Remember that the transit of theodolite takes place about this axis only. So, the next line is the line of collimation. We have already defined it. It is the optical center of the objective and the eyepiece and the intersection of the crosshair present in the diaphragm and its continuation. Look at the level tube axis. It is present just parallel to the telescope, and at the bottom or the just above the tribrach we will find the plate level axis. Remember that we are looking at the fundamental lines of a theodolite. At this point, it is important to remind you that it is an optical instrument which will measure both vertical as well as horizontal angle. In transit theodolite, the vertical axis or the azimuth axis is the axis about which the theodolite rotates in the horizontal plane. Again remember, this is a horizontal plane and this is the vertical axis. So, how we are defining it is the axis about which the theodolite rotates in horizontal plane. So, as the name suggests, it is the vertical line or the vertical axis of the instrument. After vertical axis, try to visualize the horizontal axis and look at the components of the theodolite. The turn-on axis. It is the axis about which the telescope of the theodolite rotates in vertical plane. So, we are talking about a horizontal axis and how it is rotating? It is rotating in the vertical plane. If the axis is rotating like this, so along with this the vertical plane is also rotating. So, this is how we define turn-on axis or the horizontal axis as the axis about which the telescope of the theodolite rotates in the vertical plane. The next fundamental line is the line of sight or the line of collimation, which passes through the intersection of horizontal and vertical crosshair. These are present in the diaphragm and the optical center of the object glass. Again, an imaginary line that is passing through the object center of the objective and the intersection of the crosshair and its continuation, this line is called as the line of sight or line of collimation. Now, coming to axis of level or bubble tube. For illustration, we are showing a picture of bubble tube on the screen. We look into the bubble tube. As we can see, there are some graduation marked on the tube. For line of sight to be perfectly horizontal as desired in a case of theodolite, the bubble should be at the center of the run. Now, let us define what is axis of this level. So, for that you need to draw a tangent that should be parallel or a tangent that should cross the bubble. So, it is defined as the straight line tangential to the longitudinal curve of the level tube at the center of the tube. So, from the center of the tube we can see the bubble is there. From there we need to draw a tangent. This tangent is nothing but the longitudinal tangent of the level. And when the instrument is level, the axis of bubble tube should be perpendicular to the vertical axis. It is very common if we have set the theodolite or the telescope horizontally, then it should be perpendicular to the vertical axis and the bubble will be in the center of the graduated mark in the tube. If both the cases are true, that means your telescope of the theodolite is set for horizontal reading. It is giving a horizontal line of sight. Remember, we can alter this horizontal line of sight to measure vertical angles. Now, again refer to the components of theodolite. Here we will see plate level axis. It is just over the spindles of the just above the tribrach, the spindles in the inner spindle and the outer spindle. Over that there is a plate level is there and this axis is referred to as plate level axis. It is perpendicular to the vertical axis when the bubble is at the center of the run. So, when we are actually adjusting theodolite, we are actually adjusting the level plate only such that the bubble that is there, in some cases there are two bubbles which are perpendicular to each other, but in some cases there would be one bubble that could be by adjustment of tribrach and trivette, we can adjust the plate and bring the level or the bubble to the center. This is when the instrument is leveled up properly, the plate level will be at the center. So, before start taking any reading from your theodolite, you need to have these adjustments done properly. So, now that we have learned about the various fundamental lines or the axis of theodolite, let us trace relationship between these lines and axis. When the theodolite is in proper adjustment, the following condition should be satisfied. This is a question. If you have understood the point, you will be able to answer it. What will be the relation between horizontal circle and vertical axis? Take your time and try to answer it. How horizontal circle would be placed? Horizontal circle would be placed in the theodolite like this, and how the vertical axis of the theodolite would be? It will be like this. So, what will be the relation between vertical axis and horizontal circle? Yes, it should be perpendicular to each other. When the bubble is properly adjusted, what should be the relation between the line of sight and the transit axis? Remember transit axis, it is nothing but turn-on axis. Remember, turn-on axis was a horizontal line. Try to guess the relation between them. The line of sight must be perpendicular to the turn-on axis. So, the turn-on axis would be like this, and the line of sight would be perpendicular to this. Both will be on the horizontal plane, but they will be perpendicular to each other. Again, transit axis or the turn-on axis, it should be perpendicular to the vertical axis. Again, next question. When the theodolite is properly adjusted, what should be the reading on the vertical circle when the telescope is held in horizontal position and the altitude bubble tube is exactly at the center? So, this is the vertical circle and this is the telescope. So, telescope is held or set in the horizontal position and the bubble tube is at the center. So, my question is, what would be the reading of vertical circle at this position? The answer is 0. Also remember that the line of sight, horizontal axis and vertical axis must meet at a common point. This point is called as the center of the instrument. So far, we have discussed the various components of theodolite, their fundamental lines and their relationship. Now, we will talk about the adjustments required in theodolite before we can start using it. Following are the two types of adjustments of the theodolite, the permanent adjustment and the temporary adjustment. Let us first learn the difference between the two. Temporary adjustments are to be done at every station where the instrument is set up. Without this adjustment, the instrument is not ready to take any survey readings. Whereas, on the other hand, permanent adjustment are those made to establish the relation between the fundamental lines of the theodolite, and once they are made, they last for long time. They are essential for the accuracy of the observation. The temporary adjustment includes following three operations: centering, leveling, focusing, focusing of eyepiece and the objective. In theodolite surveying or traversing, stations are the point on the ground or the survey field where the instrument is to be set up and the observations are recorded. When we place the theodolite at the instrument station, the instrument should be exactly over the ground point. Centering means setting up the theodolite exactly over the instrument station, so that its vertical axis lies immediately over the station mark. It can be done by means of plumb bob suspended from the small hook attached to the vertical axis of the theodolite. If you see the components of theodolite, a small hook is present at the bottom of the theodolite. The center shifting arrangement are provided in some modern instruments. If it is provided, it will help in easy and rapid centering process. For setting up and centering of theodolite, we follow the following procedure. Step 1. Remove the theodolite from its box carefully and fix it on the top of tripod. Tripod is a stand over which the leveling instrument or the theodolite is placed, approximately over the station where the instrument is to be set up. The tripod legs at this time should be well apart and the telescope should be at a convenient height for sighting. The next step, tie a plumb bob onto the hook provided at the base of theodolite. The center of the theodolite is adjusted by the legs and shifting the instrument along with tripod as a whole. In order to bring the plumb bob exactly over the station mark, at this time ensure that the instrument is approximately level, as this is going to save time for the next operation of leveling. When the instrument that the theodolite and tripod is so placed that they are exactly over the station mark, then the instrument is said to be centered at the station. After setting up and centering the instrument, the next temporary adjustment that is to be done on the theodolite is leveling. Like all temporary adjustment, the leveling of the theodolite has to be done at every station when the setup is done. By leveling the instrument, the horizontal plate is adjusted such that the instrument swing about the vertical axis and the horizontal plate moves in the horizontal plane only. So, again try to recollect the concept of vertical axis and horizontal plate. So, this is the horizontal plane and this is the vertical axis. So, the idea of leveling the instrument, the horizontal plate is adjusted such that when the instrument is swung about the vertical axis, the horizontal plate moves in the horizontal plane only. That means, it should not be inclined, it should be perfectly horizontal. There are two types of theodolites that are available in the market. The instrument may have 3-foot screws or 4-foot screws for leveling. The leveling operation differs slightly in these two cases. We will see both of them one by one. Most instruments have only one bubble tube, but in some instruments you may find two bubble tubes that are perpendicular to each other and they are placed over the plate. When the theodolite has 3-screw leveling head, we use the following procedure. Swing the telescope or swing the theodolite. Remember what swing of theodolite means, and bring the plate bubble parallel to any of the 2 foot screws that are available. Rotate both the foot screws either inwards or outwards to bring the bubble to the center of the run. So, there are 3 foot screws. You need to align your telescope parallel to any of the 2 foot screws, and either you will rotate these foot screws inward or you will rotate these foot screws outward. Note, there is a tip for you. The bubble moves in the direction of the movement of left thumb during this operation. So, this is my left thumb. So, if I am moving like this, if you are rolling the screws inwards, the bubble will move from left to right, and if you are rotating the screws outward, the bubble would move from right to left. So, this is the left hand thumb rule, will save considerable time during leveling. Once the bubble is at the center of the run, that is, the bubble is at the central graduation marks that are placed on the tube. Now, swing the telescope such that bubble is over the 3rd foot screw. Earlier we made the telescope parallel to the 2 foot screws. Now, we will swing it to the 3rd foot screw. Remember that we are leveling up the theodolite with 3 foot screws. Now, the telescope is on the 3rd foot screw. In this position, the bubble tube is at the right angle to the earlier position. Try to center the bubble by rotating the third foot screw alone. Do not disturb the 2 foot screws that are already used in the previous step. Now, to check that the theodolite is leveled up properly, for this again bring the plate bubble to the previous position by swinging the telescope in such a way that again it is parallel to the 2 foot screws leveled up in the earlier step. Now, check whether the bubble traverses. If the bubble has moved from the center graduated mark, bring the bubble to the center using the 2 foot screws as done before. Rotate both foot screws inward or outward to bring the bubble to the center. Note that the bubble moves in the direction of left hand thumb during this operation. Repeat this process until the bubble is at the center of the run or the bubble is at the center of the graduated mark in the bubble tube in both positions perpendicular to each other. Swing the instrument gently through 180 degree or 360 degree and the bubble should be at the center of the run in all positions, if the instrument is adjusted properly. When the theodolite has 4 foot screws or 4 screw leveling head, the following procedure is adopted. Step 1. After setting up and centering the theodolite, bring the plate level parallel to the pair of diagonally opposite foot screws, as you can see in the picture. Operate these foot screws to center the bubble, either rotate the foot screws inwards or outward simultaneously. Do not forget the left hand thumb rule, it will save you a lot of field time. When the bubble is in center, rotate the theodolite such that the plate level is now parallel to the other part or the other pair of diagonally opposite foot screws. Center the bubble using the pair of other foot screws. To cross check whether the telescope is set, swing the telescope to the previous position and check whether the bubble is in center of the run or in the graduated mark in the tube. If the bubble has not moved, that means the instrument is set, and if the bubble is not in the center, use the pair of foot screws to bring the bubble back to center of the tube. Swing it back, check the position of the bubble and repeat the position. Once the bubble is in center of the graduated mark in the tube in 2 orthogonal positions, swing it back to 180 degree to cross check. The bubble should be in the center of the graduated mark in the tube at all positions. The third temporary adjustment is focusing. We have to do focusing of the eyepiece as well as the objective. In focusing of the eyepiece involves an operation of bringing the crosshair to focus. The focusing position varies with eyesight of the observer. If the same observer is taking the reading, this need not to be done again and again. To focus the eyepiece, we adopt the following procedure. Keep a piece of white paper in front of the telescope. So, if this is the telescope, keep a piece of clear or plain white paper in front of the telescope, or else you can point the telescope towards clear sky and looking through the telescope, adjust the vision by rotating the eyepiece till the crosshair comes into sharp and clear view. So, there is at the eyepiece there is a adjusting arrangement is there. You can rotate it and bring the crosshair to be sharp and clear. Focusing the object. For this, direct the telescope towards the object and turn the focusing screw. So, adjacent to the telescope there is a focusing screw and we need to adjust the focusing screw until the image of the object appears clear and sharp. When the distance of the object is changed, the focusing has to be done again and again. Now, coming to the last part of this lecture, that is the permanent adjustment of the theodolite. The permanent adjustments are made to establish the relation between the fundamental lines of the dumpy level. Once made, they last for long time. Permanent adjustment is, as I said, is important for accurate observation. These adjustment includes, first is adjusting the horizontal plate level. Now refer to the component of theodolite again. So, these adjustment include adjusting horizontal plate level, adjustment of collimation line, adjustment of horizontal axis, altitude level plate, adjustment of telescope level, and the last one is adjustment of vertical circle. The permanent adjustment in case of transit theodolite, the first one is adjustment of horizontal plate level. The first permanent adjustment of the theodolite is plate level adjustment. The plate level adjustment is done for making the axis of plate bubble perpendicular to the vertical axis when the bubble is at the center. So, we are discussing about the permanent adjustments of the theodolite. So, when the bubble is at the center, that is leveling has been done, in that case the axis of the plate bubble should be perpendicular to the vertical axis. The second adjustment is line of sight or collimation adjustment. The line of sight should coincide with optical axis of the telescope. We started our lecture with the definition of line of sight and optical axis of the telescope. Now, the horizontal axis adjustment, also called as the turn-on axis. The adjustment of horizontal axis is done by the spire test. In this test, we ensure that the horizontal axis is perpendicular to vertical axis. Now, the adjustment of telescope level, also called as altitude level plate. The axis of the telescope level or the altitude level must be parallel to the line of sight or line of collimation. Adjustment of altitude level or vertical axis of the frame, this adjustment can be done with the help of tangent screw or clip screws present in the theodolite. Now, the last is the vertical circle index arrangement. The vertical circle must read 0 when the line of collimation is horizontal. So, for accurate reading, we need to ensure when the line of sight, that is the telescope, is placed horizontal, the vertical circle should read 0. So, very quickly we will summarize what we have dealt in this lecture. In this lecture, we started with a recap of few technical terms. We talked about the components, their applications. We talk about the adjustments that are there in the theodolite, both permanent as well as temporary adjustment. Temporary adjustment includes 3 processes, that is centering, leveling and focusing of eyepiece as well as objective. We will see you in the next class with the continuation of same topic, that is theodolite. Thank you.